the problem of finding the best route in a matrix. So in our problem, we have, this is one matrix, so here, and we need to find the best route to go into in order to maximize our profit. So for each point we have a profit amount and we want to choose the best route. So for example, for this matrix, we are going to go to 3, 7, 4, and then 9. So like this. But if we choose another route, let's say 3, 4, 6, and 3, then we get less profit. So the total profit will be 16. And we want to get the most profit, so this route is 23. So how do we find it? So we are going to use dynamic programming, which means we are going to save the result of a smaller value and then going to use this result in order to solve the big problem. So what we're going to do, we're going to go on each point, and for each point we are going to write the maximum value until this point. So let's look at the metrics of this solution. So for the first location, we're going to have the first location the same as the original matrix, and then for the second location we can get it in two ways. So we can either go just straight up, so the total profit that we can make will be 10, and the total profit if we are going diagonally will be 7. Okay, so if we just have 2 by 2 matrix, the best route will be just going straight down. So we check diagonal and we check straight down. Okay, and then we get that the best route is just going straight down for 2 by 2 matrix. And then what about 3 by 3 matrix? So we write down in the matrix itself the results. So here we are writing that the max value of the array in here is 10 and the max value here is 7. And then for each location we are checking what can be the rest route until this location. What does that mean? For 4, let's say for this, if it was 3 by 3 matrix, so we check for this location, okay, the one I'm marking right here, what will be the maximum between this route and this route. So which one is better to choose? And then we are taking again the maximum between them. And exactly the same here. So we are checking what will be the maximum of this route and this route. So we are checking what is the maximum, and then we are taking this maximum and add it into the array. So this is for 3 by 3 matrix, and let's look at 4 by 4 matrix. So this will be all of this. So how do we know? So the best result for 2 by 2 matrix will be going just straight down, and for 3 by 3 matrix was to go straight down and then diagonally. And for 4 by 4 matrix, now we need to check what will be the best route, if to go only straight down, or straight down and one right, or straight down 2 rights, etc. So how do we do it? Then we have here the result for 3 by 3 matrix as I shown previously. Now for each location we are checking what will be the maximum between the left parent and the straight parent. What does that mean? So here, let's say for this location, for 19, it will be, this is the left parent, the 12, and for the straight parent, it will be 14. Because from 14, we can go straight down into 19, and from the left, we can go, there is another way, but we choose only the maximum, hence we choose 14. And again, now we are looking at 23. So we are looking at the maximum between 14 and 13. So the maximum is 14, and then we add the value in this spot. So and we get 23. And again, we are looking at 16, and then we're looking at the left, which is 13, and the straight, which is 0. And we're taking the maximum, which is 13, and we add it into the current sum. So here we have the total is 10 and the total is 7. So now we're looking at 14 at this location, and we don't know the value at the time of computing. So how do we compute it? So we're taking the maximum, which is 10, and then we add it to the value in this location. So the value in this location was 4. So we're taking the maximum, which is 10, and then add this to the location. So let's look at the code, and hopefully it will make things even clearer. So in that in mind, so this is the actual code in order to find the best route in the matrix. So here we have two example metrics. The first one is the exactly same as here in the example, and there is another example which I will show you how to solve. So let's look at the code. So first of all, I'm getting the array. For the array, I'm taking the number of columns and rows. I know they are the same, so I just taking the number of rows, and this is the same as the number of columns. Now I'm fixing edge cases, which I will elaborate at the end of the video. The best route for the array, I'm creating a new array of this array just to be clearer about which is it which. And then for each row in range from the first one until the last one, so I'm starting at the second row, not on the first row. So I'm starting at this row. So I'm starting the second row until all the rows are done. So start from this row until the last row, which is here. So from the first row until the last row, and then for each row, I'm going on each column, starting from the second column until the row which has the same value as the column. So what does that mean? Meaning I'm going only like, because I know the rest of the matrix is 0, I have no reason to actually go and calculate each other point. So I'm just going at the point which is possible even for a route. So this is how we're looping over the metric. And first of all, I'm calculating what is the best route going just straight down, because we have only one way to go straight down, which is just to go straight down, because in the rules of how we move in the matrix, we say there is only two options. You either can move diagonally or you can go straight down. So if you are getting to the bottom left corner, it means you only went straight down. So we are calculating actually the value in this location, and then for each column, so which mean for this one and for this one and for this one and for the rest of them, we're taking the left parent and the straight parent, and now we are adding the maximum into the value of this location, and we're setting this as the new value in this location. So this is what we are doing, what I described in the algorithm, and we're returning this max value. So let's debug and let's see what is actually happening. So we are running this file, and then we can see, so the best route is the same array as we can see here. So 4x4 matrix, and let's keep the loop going and see what's happened. So here what's happened for the bottom left corner. So the bottom left corner, as you can see, is changed to be 10, because if we're summing out only going straight down, it will be 10. So 3 plus 7 is 10. And then we're keeping now we are starting the loop, and for each column starting from 1 until 2. So now we are at column number 1 and row number 1. So let's look. The left parent is 3 and the straight parent is 0. So we're taking the maximum, which will be 3, plus the location we are at. So the location we are at is 4. So 1, 1 is, the value is 4. So the total sum will be 7. And now we're keeping the loop. So now we're in the third row. So the third row, let's calculate. Okay, so now it's changed. So the third row, the first element, so the bottom left element, now is 12, because if we are summing 3 plus 7 plus 2, it's 12. And then for each column we are looping, we're seeing the left and the straight parent. So the left parent is 10 and the straight parent is 7. So we're taking the maximum of this, and the maximum will be of course 10, and we are adding it into the location we didn't calculate, which is 4 now. So now the total will be 14, as you see here. And let's just look at it. So here you see the 14, and now we are for this location for 6, we're going to check the left parent and the right parent. So the left parent will be 7 and the right parent will be 0, so we're taking 7. 7 plus 6 will be 13. So again, now for the last round. So we have already calculated what will be the bottom left corner, and now we need to calculate the rest of the location. So 5, 9, and 3. So for 5 it will be the maximum between 12 and 14, which is 14 plus 5, which is 19. For 9 it will be the maximum between 4 and 13, so the maximum is 14 plus 9, 23. And for 3 it will be 13 and 0, which is 13, plus 3 is 16. Okay, so now we're retaining the maximum in the last row. So the last row gives us the best route in order to get to this location. So we know we need to choose the best route. So the best route will be going into this location. So it's 23, and we're returning the maximum as they ask for, and we're printing it. So that's it. And let's look at another example. And guys, please like and subscribe to this video now. Okay, let's look at this example. So now we have the same array, different array of course, but the same problem, and we want to choose the best route. So let's look. So for this location we calculate this is 12 again, and now we are adding this location, so 12 and 12, and this is actually making sense. So this location are the same because in this array they have the same value. So 18 plus 4 and 18 plus 4, 8 plus 4 and 8 plus 4, it's 12. So let's keep the loop going, and then we can see now we calculated both of this location, and we need to calculate the 6. So the 6, just let's look at it. It will be the maximum between 12 and 0, so it's 12, and the value will be 18. And like that, we calculated that, and we have the best route, which will give us 19. We can see that in a minute. Let's look at the array before we're returning it. So 8, 12, 12, 4, 14, 14, 18, and because all of these values were 1, then the best value was actually this one, or the one with 18. So 19 is the best route. So that's it for this video, guys. Please like and subscribe for more videos like this, and until next time, I'm out.